Yes, my dear children, good afternoon to all of you. Today we are going to discuss the sums in the exercise 5.1. We have discussed 18 questions so far in this exercise. I hope you have learned
Good
well.
afternoon, sir.
Yes, good afternoon, my dear Kiran Raj. I hope you have understood well. You have learned well the 18 questions in this exercise 5.1. Now come to the question number 19. This question is based on the concepts of greatest integer function, or it is also called step function. So in your earlier class you have studied, it is denoted by square brackets like this, square brackets like this. So we define greatest integer function as, suppose n is an integer. Suppose n is an integer. N belongs to I means n is an integer. Then step n value is n only. Step n value is n only. Suppose step 5, 5. Step 6, 6. Step minus 10, minus 10. Step minus 3, minus 3. If the number within this square brackets is an integer, then its value is the same integer. Whatever the integer you are taking, that number itself is a function value. Now, if n is not an integer, if x is not an integer, in this case, if it is not an integer, in this case, how do you define step n? Where or this like this. Here, step x, it defines step x. If x is not an integer, if x is not an integer, x is not an integer, then step x is defined as n minus 1, where n minus 1 less than or equal to x less than n. To understand this definition well, let us take some examples. Step 1.3. 1.3 is not an integer. It is not an integer. It is a rational number. In this case, we have to identify on the number line in which numbers, between which numbers this number lies. 2, 1 and 3. Between 1 and 3. So, at most left number, the nearest integer to this left of this number, left to this number. Similarly, suppose step 2.5. Step 2.5. This number is not an integer, but it lies between 2 and 3. It lies between 2 and 3. Yes or no? So the nearest, the utmost left side of this number is 2. Step 1.9. 1.9 is not an integer, but it lies between 1 and 2. This number lies between 1 and 2. So its function value is 1 only. Its function value is 1. Minus 3.7, it is not an integer. Minus 3.7 is not an integer. It is a negative rational number. Negative rational number. This number lies between -4 and -7, -4 and -3, between -4 and -3. So the leftmost integer to this number is -4. So its function value is -4. Step -3.9. Its value, this is also not an integer. This number lies between -4 and -3. If you mark this number on the number line, if this number lies between -4 and -3, exactly between these two integers. So the leftmost integer is -4. Can you tell me what is the value of this function? Step -0.3. Step -0.3. You have to identify on the number line. You have to identify this number on the number line between which integers, which integers this number lies. Actually, this is not an integer. This number lies between
-1 and 0, sir.
-1 and 0. Very good. So what is the value of this function?
-1, sir.
-1 only. -1. That is why I told you previously, in the previous chapter, in the previous class, I told you just once go through the definition of greatest integer function. So now come to the question number 19. Here f of x is equal to x minus step x. Given f of x is equal to x minus step x. And what is asked here? Show that the function is discontinuous at all integers, at all
Sir,
integral
it's given as
points.
g of x is equal to x minus. It's not f of x, sir.
Oh, okay, g of x. G of x. You have to show that this function is not defined, it is not discontinuous, it is not continuous, or it is discontinuous at all integral values, at all integral points, means at integers, at all integral points means at all integers. This function is discontinuous. We have to show this. Okay, let a is an integer. Let us consider a is an integer. Okay. Then what is the value of a? If a is any integer, then what is the value of a? Tell me. See here. If a
Yes,
is
sir.
an integer, what is the value of that
Yes,
function?
Yes, sir.
A only, A itself. A itself. Can you tell me? H is greater than 0. H is greater than 0. Means it may be 0.1, 0.2, 0.3 like that. Here it is a very, very small positive integer. H is a very small like this. 0.3, 0.5, 0.1, 0.2, 0, see here like this. Can you tell me value of this function? Step of 7.0003. What is the value of that function?
7, sir.
7 only, that's all. Here 0.003 is said to be h. said to be h. Okay, so a minus h. If you take a minus h, then the function value is a, and step a plus h. A plus h means a only. If you take h is a positive integer, then a minus h gives a minus 1, and a step of a plus h gives a, means this one 2.5, 2 plus 0.5, 2 plus 0.5. Okay. Suppose if I take, for example, suppose if here I have taken h value 0.1, a minus h. Let us find the value of this function. 5 minus 0.1. What is the value? Yes or no? Step 4.9. What is the value of step 4.9?
4, sir.
4. Here a means 5, a means 5, h means 0.5. So a minus h, what is the value of a minus h? 4 means 5 minus 1, so a minus 1. Step a minus h value is a minus 1. Step a plus h means this one, 1 plus 0.3, 2 plus 0.5, 1 plus 0.9. Then their function values are 1, 2, 1 like that. So you have to observe these examples and connect this connect this concept to this question. Now let us find LHL and RHL at point A. At point A. Then as extends to a minus limit g of x is equal to, as extends to a minus means we have to take like this. We have to take like this only. A minus 1, a minus 1. Here in the place of a minus step of a minus 1, step of less than means this one only. Left side value is a minus 1. So or like this also, x minus 1. So a minus a plus 1. So this is the left hand limit of this function at x is equal to a. This is the right hand limit of g at x is equal to a. So as x tends to a plus means greater than a. X value is greater than a. So we write a minus of a plus means here a plus h. We have to take this value only. So a minus a 0. So left hand limit is 1 and right hand limit is 0. Both are not equal. Here LHL is not equal to therefore G is discontinuous. So it is discontinuous at all integers. Okay, my children. Take the screenshot. Yes, take the screenshot of this page number 1.
Taken, sir.
Yes. Let me show you this. Like this. Elections too. Now take the screenshot. Yes. Now come to the question number 20. Do as it is, find the directly find a limit of that function. Okay. See that question number 20 is the function defined by f of x is equal to x square minus sin x plus 5 continuous at x is equal to pi at x is equal to pi. So directly find limit of the function at x is equal to pi and the function value. Directly find limit. No need to find left hand limit and right hand limit. Okay, my children. Will you try this one? Now, question number 21, discuss the continuity of the following functions. This question is the same as that of question number 3. See here, in the question number 3 also, no point is mentioned. See here, same as the question number 3. Here also take any real number, let A belongs to R, and check the continuity of these functions. All functions are continuous functions only. Okay. Let's discuss the continuity of cosine function. Cosine function is always continuous for all real numbers. For all real numbers, it is a continuous function. Cosecant, at which point cosecant is not defined at x is equal to n pi. At all these points, it is discontinuous. Secant, odd multiples of pi by 2. Odd multiples of pi by 2. At all the odd multiples of pi by 2, cosecant is discontinuous. See this figure. In that inverse trigonometric functions, we have drawn the cosecant graph, cos graphs here, where the curve is cut. At which points the curve is cut, find out the points at which the curve is discontinuous. Similarly, find out, see here, observe the graphs. Just by observing the graphs of secant x, cosecant x, and cot x, okay, then write the points of discontinuity. Will you try these points of discontinuity for these questions?
Okay, sir.
Go through the graphs. With the help of graphs, you can identify easily. You can find the points of discontinuity of these cosecant x, secant x, and cot x. Just to find all the points of discontinuity of f, where, see the question number 23. See the question number 23. Question number 23. My dear children, this week write the test.
So your voice is breaking, sir.
Okay, network issue it may be. I'm planning to conduct a weekly test on determinants 4.4, 4.5 and 4.6 in these three exercises. On which day of this week will you write the test? Friday? Okay, please prepare well. 4.4, 4.5, 4.6 in the determinants chapter. Okay. Will you prepare well?
Okay, sir.
Yes. Again, I will post this message in the WhatsApp group as well as in the Google Classroom. Today itself, I will post it. What is the portion for the weekly test and day of the test. Question number 23. Find all the points of discontinuity given f of x is equal to sin x by x if x is less than 0, x plus 1, x is greater than or equal to 0. X is greater than or equal to 0. Same as this question is also previous question, same as that of question number C. Question number 6, 7, 8, 9, 10, we have found points of discontinuity. Same as that of question number 6, 7, 8, 9, 10, 11, 12. We have found points of discontinuity. Here also we follow the same procedure. We follow the same procedure to find the points of discontinuity. At which point the function is defined differently in two ways. At which point the function is defined differently?
0, sir.
At point 0 here. So here then what is f of x here? Tell me. F of x. X less than 0. Here f of x is equal to
x plus 1.
X plus 1. Exactly at x is equal to 0.
X plus 1.
X plus 1. So let us find left hand limit, right hand limit and function value. So left hand limit as x tends to 0 minus limit f of x is equal to as x tends to 0 limit. If x is less than 0, x tends to 0 minus means x is less than 0. Remember this point. If x is approaching to 0 minus means x is less than 0. Then what is f of x here? Sin x by x. We know that this is a standard limit. As x tends to 0, sin x by x is equal to 1. Sin x by x is equal to 1. Here we are not using direct substitution method by standard limits formula. As x tends to 0 plus f of x. So as x tends to 0 limit, what is f of x here? X plus 1. So 0 plus 1, that is equal to 1. So both are equal. Let us find f of 1. F of 1. So, sorry, f of 0. So all these values are equal. All these three values are equal. So it is continuous for all real numbers. There is no points of discontinuity. Okay. And x tends to 0 minus limit f of x is equal to as x tends to 0 plus limit f of x. Therefore, f is continuous at x is equal to 0. There is no points of discontinuity for this function. There is no points of discontinuity. Okay, my student. Now take the screenshot of this page number 2. Take the screenshot of this page number 2.
Second, sir.
Yes. See the next one. Question number 24. See the question number 24. See question number 24. So before going to discuss this question number 24, we have to learn this point. There is a theorem that is called sandwich theorem. Sandwich theorem or squeeze theorem. Squeeze principle. This is a little bit different question, variety question. By using this principle, by using this sandwich theorem, we determine the continuity of this function. If f, g and h are three functions such that f of x is less than or equal to g of x is less than or equal to h of x. These three functions are like this. For all x. For all x values, these three functions are like this. For all x in the deleted neighborhood of A, and as x tends to A, limit f of x is equal to L, and as x tends to A, limit h of x is equal to L. If both functions have the same limits, then the middle function also have the same limit. Then, as x tends to A, limit. So all these three functions have the same limit. Based on this concept, based on this sandwich theorem, this is also called squeeze principle. This is a little bit variety question in this exercise. So with the help of this concept, we find or we discuss the continuity of this function. Okay, now come to the question. Given f of x is equal to f of x is equal to x square into sine 1 by x if x is not equal to 0 and f of x is equal to 0 if x is equal to 0. Here what is asked? Discuss the continuity of this function, whether it is a continuous function or not. Whether it is continuous function or not. At which point? At which point?
0, sir.
Yes, at point 0. At point 0, we have to find the continuity of this function. So, directly we cannot find the limit of this function. That is why we are using this concept. We know that yes or no, sine function values always lies between -1 and 1. Range of the sine function. What is the range of sine function? Closed interval -1, 1. Yes or no? Whatever
Yes,
the
sir.
angle you take here, whatever the angle, whatever the bigger angle, whatever the negative angle, whatever the angle, if you take, then it's a sine function always lies between -1 and 1. Okay. This is a very important step to discuss the continuity of this function. So here what is given? X square into sine 1 by x. So multiply entire this inequation by x square. So minus x square less than or equal to x square into sine 1 by x less than or equal to x square. Now we take the limit as x tends to 0, limit minus x square less than or equal to as x tends to 0, limit x square into sine 1 by x less than or equal to as x tends to 0, limit x square. Then what we get? What is the limit of this function? Can you find? What is the limit of this function? Can you find the limit of this function? Direct substitution method. Use direct substitution method. What is the
0, sir.
0, sir.
Less than or equal to as x tends to 0, limit x square into, this is nothing but f of x. Yes or no? So as x tends to 0, limit f of x given function less than or equal to, what is the limit of this function?
0, sir.
That substitution zero. So the limit of this function lies between 0 and 0. Can you find any number? Can you find any number between 0 and 0?
No, sir.
0, sir.
0 only. So limit of this function is also 0. This implies as x tends to 0, limit f of x is equal to 0 by squeeze this rule. This side function limit is 0. This side function limit also 0. So middle function limit is also 0. So we got limit of this function. Now f of 0. F of 0 is 0. So as x tends to 0, limit f of x is equal to f of 0. Therefore, f is continuous at x is equal to 0. Therefore, f is continuous at x is equal to 0. Okay. Now take the screenshot of this page number 3. Yes, have you taken the screenshot? Now come to the question number 25. Examine the continuity. Please try the question number 25 by yourself. Try the question number 25 by yourself. There is no twist. There is no difficult point in this question number 25. Directly find the limit of the given function at x is equal to 0 and find f of 0. That's all. There is no twist. There is no twist. There is no difficult point for this question number 25. Now come to the question number 26. Find the values of k so that the function f is continuous at the indicated point in the exercise 26 to 29. So 26, 27, 28, 29. All these four questions are of the same type. All these four questions, 26, 27, 28, and 29. All these questions are of the same type. You have to find the value of k if the given function is continuous at a given point. See here, given f of x is equal to k into cos x. This is important model, my dear children. In this exercise, this is important model. K into f of x is equal to k into cos x by pi minus 2x. If x is not equal to pi by 2, and f of x is equal to 3 if x is equal to pi by 2 is continuous. At x is equal to pi by 2, it is a continuous. It is given that this function is a continuous function. But find the value of k. Then find the value of k. Okay. So to find the value of k, we use this point. As x tends to a, limit f of x is equal to, as x tends to 0, limit f of a plus x. Or sometimes we can use as x tends to 0, limit f of a minus x. We use this point to find the limit of this function. Okay. Now, at which point here function is continuous at x is equal to pi by 2. So let us find as x tends to pi by 2, limit f of x is equal to as x tends to pi by 2, limit what is f of x, k into cos x by pi minus 2x. If you follow direct substitution method, you get 0 by 0. That is why we use any one of these two. Any one of these two. So, you can use this one or this one as x tends to 0. Limit k into cos of, here m is pi by 2. So pi by 2 minus x by pi minus 2 into, in the place of x we are writing pi by 2 minus x, because as x tends to a, limit f of x is equal to, as x tends to 0, limit f of a minus x. So by using this rule, we can find this one. So as x tends to 0, limit cos pi by 2 minus x, we get to sin x. Sin cos 90 minus theta. Pi multiply, here distributive property, minus pi plus 2x. Here plus pi minus pi gets cancelled. Okay. As x tends to 0, Okay, I'm ready to done. Up to there, note it down. Take the screenshot. Take the screenshot. I will continue. Just two more steps. Just two more steps. Take the screenshot fast.
Taken, sir.
Yes. See, next step. That is equal to 1 by 2, we write k by 2 into as x tends to 0 limit. Here k and 2, they are not affected by limit. So we are writing that k by 2 outside. So k by 2 into here limit of this function is 0 as x tends to 0 limit sin x by x standard limits. That is k by 2. This is limit of this function. Now f of pi by 2. It is already given f of pi by 2. F of pi by 2 is given as 3. F of pi by 2 is given as 3. Therefore, as x tends to pi by 2, limit f of x is equal to f of pi by 2. Because f is continuous, it is already given. It is given that it is already continuous function. So, as per the definition of continuous function, as x tends to a, limit f of x is equal to f of a. So, what is the limit function? Limit of this function k by 2 is equal to f of pi by 2 is 3 by cross multiplication 2 into 3. This is the value of k. This is the value of k. Okay, my student, take a screenshot of this page number 5. Take the screenshot of this page number 5. And you try the question numbers 27, 28, 29. Same procedure. Follow the same procedure and find the value of k. Have you taken a screenshot?
Yes, sir.
Will you try the question number 27, 28, and 29? Remaining three
Yes, sir.
questions. Finding the value of k, same procedure. Will you try that 3 questions?
Yes, sir.
Now 30 also, you can find it 30 also. Question number 30 also. Question numbers, homework. Try these 4 questions. Try these 4 questions. Note it down the homework or take a screenshot.
So you also told to do 20, 21, 22, and 25 now, sir.
Yes, sorry. These also, these questions also. 21. Yes, 21. 22 also. 21, 22. 21, 22, 21, 22, 25, 25, 27, 28, 29, and 30. These are the homework sums. Please try the homework sums. Don't escape in doing your homework sums. If you have any doubts, ask your doubts and get your doubts clarified. Previously also I told you clearly, don't escape in learning the subject. In improving the knowledge, don't escape. Okay, now the time is 2 past 22 minutes, my dear children. You can leave the meeting, take rest, take care of your
Thank you,
health,
sir.
my dear
Thank you, sir.
children. Stay at home, stay
Thank you,
safe.
sir.
Thank you, sir.
Prepare for the weekly test. Prepare for the weekly test. Determinants 4.4, 4.5, and 4.6. 3 exercises.
Thank you, sir.
Thank you all, my dear children. Thank you all.
Thank you, sir.
Thank you, my dear Joseph. Or my dear Ayush, still you are online? Ayush Singh, are you there online? Are
Yes,
you,
sir.
Why are you staying back? Tabab,